Hey guys, I'm Nick and welcome to another tutorial. Today we will be creating this kinda, I don't know, reverse stitching effect or disintegration to the strands or something, but it's a really cool effect that is based on one of my previous tutorials that covers creating advected splines from particles that are driven with pyro, and this tutorial is packed with different concepts and different tips that will help you in your own projects, whether it be pyro simulations, UV unwrapping, and all that stuff. So yeah, let's get into it, and let's start with overall setup. Here you can see that I'm using one HDRI material network, two cameras. Camera 1 is actually what's being rendered, and camera 2 is just for my own preview. Yeah, we have a grid that's just a backplate, our strands, they appear here, and of course our shirt. So yeah, let's go and check out strands because it's where everything happens. Yeah, so my shirt is something very basic from the Marvelous Designer. I think I made it a while ago, and yeah, it's nothing fancy here. Doesn't have any outlines, but yeah, works pretty good for this case. What I want to do is make sure it's proper size. Let me select this transform here, and in this one I just press this move centroid to origin, because if we select it here and perhaps drop another transform here, now you can see that our pivot point is in the 0, 0, 0, but our mesh is somewhere here, so we need to drop that mesh to the origin point, which is 0, 0, 0, and then I have this another transform where I basically scale it down a lot and add a bit of, the rotation, so it lays down somewhat, not like organically, but not that boringly straight, From the Marvelous Designer or Claw 3D, your mesh will have UVs, and you can press Ctrl 2 or Command 2, and here in this button here, which says stop, you can set the view to be UV viewport, and you can see that we have some sort of a layout here, but I want it to be a bit more efficient, so I dropped this UV layout node, and you can see it says also the coverage, and I'm not that particularly worried about coverage because yeah, the texture will be pretty big. I just modified the apply padding between islands and target boundary and spread islands to all available space. And also I wanted a bit more island padding, so I increased it. If I uncheck the spread and apply, you will see that it basically, yeah, it takes more space. And if I remove the island padding, it will rearrange it, and our coverage percentage will go up. But yeah, I wasn't sure what texture I will be using, that's why I wanted a bit more space between them. And basically, here's our front part, here's our back part of the t-shirt, here are two sleeves, and these are just like small details, small edges here on each sleeve and for this neck part. Let's get back to our single view, pressing Command or Control 1. And yeah, for this one, I basically want to apply some wind with the vellum. So I drop a vellum class. What I have changed here is just changing this stiffness multiplier to 0.01. And here in the vellum solver, I remove the gravity completely. And if we dive inside, you can see the pop wind here, which I set to amplitude be 0.4 and swirl size 4. And now if I play that animation, which should be pretty quick, but yeah, you can see this really like subtle movement here. Nothing too crazy. I have actually file cached it, and before we file cache, it's good to delete all the attributes, but keep the UV. So here I checked delete non-selected here, and then it basically deletes everything that is not selected. And in our case, it's all the attributes except the UV. So here you can see that we have just our position that will be by default. You cannot delete the position attribute, but we have our vertex attribute UV. And yeah, I file cached 210 frames. You can see it here. If I play it, it's just very subtle. Yeah, subtle movement. Oh, and yeah, actually, it's incorrect because I was actually rendering 180 frames, so we wanna set this all to be 180. But yeah, still you see that just a little bit of wind. So then we want to colorize this t-shirt, and of course we will be using textures in our shaders, but here we want to get our texture and kind of colorize our mesh, our vertexes, assign the vertex color from the PNG texture. So if I click this attribute from map, you can see that we have a bunch of different different abstract objects here. And actually I want to talk about the UV layout a bit, because here's the deal. We want to export our map, right? That one that we saw here. So you can right click on this UV layout node and click here on save and texture UV to image, and then here you select I selected just a plain PNG, I think, and resolution, of course, you want to go with 2048 or even 4K if you want. But yeah, basically then you click accept and export your UV map. And here is my Photoshop window where you can see, let me remove these, and here's our UV layout, which then we can colorize as we want. And I want these little outlines on the neck and on the kind of edge of the sleeves to be bright white color. Yeah, then I found this on free pick, this abstract drawing. The author of this is raw pixel. It's free with attribution, and yeah, I just like added it here to this part, to the front part of the t-shirt. And then yeah, I think then I just like added a color overlay and picked the color from this texture here. And yeah, that's how you set up the texture. Just don't forget to uncheck this UV layout layer. And yeah, that's how you create these textures in Houdini. So let's get back to our attribute from map. What we want to get here is select our texture map here, and in texture channel we should use color, which is C, export attribute CD, and yeah, that's basically it. Source color space automatic, and yeah, for this project we will need to reference our t-shirt a few times, actually just one time, but anyhow, here we have our null, which is called out t-shirt, which is just this plain t-shirt. So yeah, after our attribute from map, we can start building our pyro that will influence our particle advection that we will then convert to strands. So the thing with the pyro is that we will be using pyro source spread, and in a minute I will explain you how the pyro dynamics work. But first of all, yeah, we want to create a heat group, which is basically a set of points, group name heat, group type points, that then with attribute create we can create the temperature for our group heat and set the value. In my case I set the value to be 10. So these particles will be kind of already burning, and I will visualize the pyro source spread, but for now we need to drop this pyro source, and here we want to click here, initialize source smoke. And particle separation should be set to 0.05 in my case. I think it's a good balance between speed of the simulation and actual kind of detail of the smoke. Then we go and drop pyro source spread. So here what we want to select is cooling rate to be 0. For the diffusion, you should play with these values because they basically influence how fast your flames, your burn will spread. And also I changed the noise types to be sparse convolution and element size to be 0.6. For the fuel, so here's the deal. We wanna burn it once. We don't want it to be burning like a candle. We wanna pretend that we have sort of a fuel that burns out, and that's it basically. And what I want to show you here is that, yeah, initial fuel set to 1, injection rate set to 0. And if we visualize the burn here, and yeah, here you can see how these parts, you can see that it basically goes and burns only at that edge where it's spreading. It does not burn consistently here. If I set the injection rate to be 1, as it is by default, and I will reset the simulation, now you can see that it burns forever because we are injecting and injecting and injecting that fuel there. So let's keep it at 0 for now. Yeah. Then we drop a volume rasterize attribute, and here in the voxel size you can see that we are referencing our pyro source particle separation. We can click on this one, right click, copy parameter and paste relative references, and now we are referencing that parameter from the pyro source. So here, of course, we want to rasterize burn, density, and temperature. And then we get to our pyro solver. So with that pyro solver, there's also an interesting thing here. Let me just enable the file cache for now so we get to it a bit quicker. But yeah, let's go and check all of these settings here. So voxel size, it's the same reference that we had in volume rasterize attributes. Then for the bound, I select the boundary to be -10 by y-axis, so it's not infinitely spreading to the bottom. You can see that at some point it starts breaking with this boundary here that I set to be -10. For the sourcing, I think it's all default. I just unchecked the limit source range. And then for the fields, actually dissipation set to 0.03, so it doesn't dissipate that fast. For the shape, here's the buoyancy. Gravity acceleration set to 2 and gravity direction set to 1. So actually buoyancy pushes all of that down. Disturbance and turbulence is set to 0.5 and 0.4. And for the look, so I uncheck as assign material because we don't need that. For the smoke, it's all default, and for the fire, it's also all default. But I want to show you how that fire influences our smoke, because here's the deal with the pyrodynamics. If the area has fire, it means that there is hot air, and hot air has a lot more buoyancy than just smoke, just like volume that is basically cold. So here you can see that as we have our burn going through our mesh, you will see that these areas that have been just burned, they actually move away from their initial position. You can see that we barely see any movement at the other parts of our mesh. And as the flame goes, you can see how it actually displaces that smoke. And that's basically physics, you know. Yeah. here you can see it basically how it goes and how it dissipates and moves the smoke. So for our convenience, after our file cache, I dropped out smoke, and we are ready to eject some particles from that smoke. But before we do that, there's actually no, actually, let's go and set up the spline animation, the strand animation. So what we want to do here is just after our pyro source spread, we drop our null out spread, just to kind of visualize that it's the end of one logical chain, and then we proceed with that output to another logical chain, which starts with this attribute triangle, which is at ptid equals ptnum, and this is just to store all the points that we have initially because we will need them. And then we want to get and create kind of like a group that will be emitting points in our popnet. And what I want to do here is to get a bit more strands, a bit more particles, I want to blur the burn parameter. And that's done because I want all the points that have burn parameter greater than 0, I want them in a specific group that will be emitting the particles, and then we will be converting these particles to the strands. So here's the deal. If we remove this blur burn, which is basically attribute blur node, and let's go and simulate, you can see that we have pretty narrow line of these particles that will be emitting other particles. But if I add this attribute blur, now you can see that we have much more particles that will emit strands, and more strands means more messy and more chaotic, but also more organic a look. So I suggest you playing with these settings here. For me, I'm blurring the attribute called burn, blurring iterations 2. If we set this to be like 14, you can see it goes too much. So yeah, something around 2 should be good. Step size 0.2. Influence type set to proximity and pin border points is unchecked, and you can also play with this proximity radius or max neighbors. Yeah, max neighbors, I think. So yeah, now when we created our group, which in my case is called active PT, and it's a point group, so group type set to points, and base group expression set to add burn more than 0. Now we can drop a popnet, and here we have our pop network. So first of all, source first input is set to all points and use first context geometry, and source group, this is very important, should be set to active PT. So if I remove all of these, maybe, yeah, pop win should stay here. If I remove all of these and play this simulation, you can see how our active PT group is growing and emitting the points. But of course, this is unbelievably boring, and that's why we drop this pop direct by volumes. In the sub pass, we specify our out smoke, velocity scale 1, velocity blend, in my case it's set to 0.6, but again, you can experiment with anything from 0.3 till I think 1. Let's at least enable that and see what we got here. And yeah, we have our particles advected with our smoke. So this does not look like splines or strands, and that's why we again go in our sub solver here. After pop and divide by volumes, we drop a sub solver, and we need to do a few magic tricks here. So let me organize it just a bit, and here's the deal. So what do we want to do first of all? We want to drop this add node and switch to the polygons tab and switch to by group tab. Change this add to by attribute and use our PT ID that we specified before. Use that here in that add. And if we play our simulation, you can already see that we start to have some sort of these trends. One thing that I wanna turn off is here in the pyrosource spread where we were visualizing our burn. Let's set it to none. Let's go back to our pop network, and yeah, we have our strands, but they are not looking very pretty, so we want to resample them. In my case, I have set the resample to be 0.07 in length, and important thing is to check this create only points checkbox, because we want to create only points in this scenario. We don't want to create lines, but still, then we want to drop this convert line node, and yeah, it's basically just drop that convert line node. Because of that, we can now go back, select our popnet. Let's maybe simulate a few frames here, right? Till the frame, let's say 60. And now, if we drop the add, which is 100% identical to the add that we used in the popnet. So we go to the polygons tab, to the by group tab, change the add parameter to by attribute name ptid. Now we have our lines, and they are looking pretty good, I would say. So of course we want to cache them out, and yeah, you can see how they very quickly they get out of hand, and yeah, expand very drastically. One thing that you might want to check here is this carve soap, which actually I ended up not using, but basically if it's too much for your GPU or CPU or whatever, you can select this carve soap, and in this one play with this first U, and basically you can, let me just go back to the frame, I don't know, maybe something like, yeah, frame 83, and yeah, you can play with this carve soap first U parameter, and yeah, maybe somehow kind of like make it all looking a bit thinner. But for me, I actually haven't used that carve soap, just wanted to share with you. And now you can see that because we have used our attribute from map and we transferred our colors from map to the points, now our strands are also colored in the same way that our texture have. So for the strands, it's yeah, basically that's it. But I want to talk about the shirt animation here, which you can see is right now missing a few polygons. That's because I wanna remove these polygons, and there are two things that we can do. First of all, of course we transfer some color data, right, that I will talk about a bit later, and we can use this data, this black and white, to set our shaders opacity. So all the black parts will just become transparent, but also we can go a bit extra and actually delete the geometry. So the main thing here is that we wanna kind of somehow grow the group that was burned. And the main problem with that was that if you remember our create active PT group, it doesn't store the particles that had been burned. It just updates it all the time, and it's correct behavior in this particular case because we want to emit strands only when that particle is burning. We don't want to emit additional particles for all the points that has been burned sometime in the past. So what we want to do here is drop a solver, and this solver should be attached to the pyrosource spread. And in this solver, it's actually very easy setup here. So I can delete this comment and explain it in my own words, because yeah, I was adding that comment to myself late at night yesterday. But yeah, the idea here is pretty simple. If the point was burning in the previous frame, we want to add that point to the group, and we want to store that group. That's it. So I can get the burn parameter from the point using this point function, where I specify that we want to get the point from the first input, this input 1, that goes into the first input of our attribute triangle, because 0, 1, 2, 3. And yeah, we get a burn parameter from that point. And if previous burn parameter, prev burn, which is a local variable that I created here, if that prev burn value is more than 0, then I'm using this function setPointGroup, which refers to the geo handle, which is 0. The group name will be burnedpt, and then we specify the point number that we want that point to be included in that group. Operation 1 is basically says that we want to add that point into our group, and yeah, set basically again sets that point in the group. If we now visualize, or actually colorize, all of our points to be white, and then we colorize only that group that we have just created in wax, which is called burnedpt, we colorize that to black. Now you can see that it works, and we have all the particles that had been burned, we have them in a separate group. And yeah, of course, then we drop null and call it outBurned. So then we can move to the t-shirt, because here what we have is we merge shirt and we merge our burned outputs. We merge them using object merge. We just reference them here, and then we have this attribute transfer node. So for our strands, let me just get back to our file cache, and for the t-shirt, now we are using this attribute transfer, max sample count set to 30, and attributes transferring just all attributes, right? Because I don't know what attribute we might need, but essentially when we transfer these attributes, we also transfer the color data from the shirt and burned outputs. And pay attention here that both burned output and both shirt output does not have any color data, not like the color data, but the colors from our UVs. It's all just black and white, and that's because we basically don't need these texture colors here in our shirt geometry, just because for this geometry we will apply the shaders. So yeah, the attribute transfer those colors, and then we can just delete points, delete by expression, and filter expression is just if CD red channel, but you can pick in this case you can pick also green or blue channels. If it's less than 0.0001, it's just like random number. We basically delete these burned points. So yeah, I think now if we combine our shirt and our strands, and for our strands we definitely want to go for this last file cache, visualize that, you can see that we have our strands. So also in our popnet we could add the static object which links to the out shirt, and we should check deforming geometry, use object transform, create active object, and display geometry if you want. But then it basically prevents the strands to go through the mesh, but it burns so quickly that I actually like that mess that it produces, and I don't want it to be colliding with something. I don't know, if we play, now you can see that we have all the strands kind of going outside, but I think it was better when these strands also went into our t-shirt, like these here. So yeah, it's up to you with this one. I think we are done with our technical setup. Our camera is just default vertical camera and focal length set to 80. Let's fire up the render and talk about the materials here. So here's our shirt. For the lights, as I said, I'm using just this Photo Studio that I got from HDRI Heaven. Yeah, shirt, strands, grid. Let's maybe remove the grid for now. But yeah, essentially, let me also adjust the materials real quick. So this will be shirt material, this will be strand material, and this will be, of course, our grid material. So yeah, a few things here. Of course, we want to render our strands as strands, right? So we go to the redshift obj, strands, render objects as strands, strand type cylinder, global scale multiplier 0.05. And yeah, actually that's it. For the materials, let's check them separately. Let's go into the MUTNet. So what we have here is our shirt material. I have my texture, which is this shirt texture. I have it into the diffuse channel. For the bump map, I'm actually using normals from like some random texture from the internet. I think I googled just like cotton fabric normal map. I plug that into the bump map, change the input map type to tangent space normal, and don't forget to change the color space of our normal map, and roughness and normal maps should be row, so color space is changed to row. And yeah, then we also wanna use our color data to actually drive our opacity. So let me remove the strands, and here let me also, in the shirt, let me stay at this attribute transfer node. What we have here is particle attribute lookup, attribute name CD, and it goes into the overall opacity channel. So if I remove it, you can see that we have we are losing that cool transparency transition, you know. But if we go with the delete node, now you can see that we maybe don't need to use shaders, but I think it's pretty rough. So definitely, yeah, let's plug the out color to the overall opacity color and maybe restart the renderer. Yeah, I actually like that this edge here has a bit of fade. Yeah. For the strands, yeah, also particle attribute lookup goes into the diffuse channel, roughness 0.87. Yeah, strand material. For the grid, just white, absolutely rough material. Yeah. For the redshift settings, actually, I'm rendering 180 frames. Output set to PNGs. Minimum samples 8, max samples 512, threshold set to 0.001, overriding reflections and lights, global illumination set to brute force and brute force 8 and 1024. Yeah, I think that's actually it for this simulation. Alright guys, I think it's all for today, and I really hope that you learned quite a few new tricks about Pyro, about UV maps and using UV maps to coloring vertices. Maybe you have learned new stuff about Pyro advection and creating strands from the particles. Anyhow, if you have any questions, please feel absolutely free to reach out in Discord or in Patreon comments or messages, whatever. I will do my best to answer your questions as soon as possible, and I'll see you guys next week for another cool tutorial. Bye!